Hello, this is Dr. Brown. In this lesson, we're going to cover 9.2, which is the law of sines. The law of sines is some additional theories in trigonometry that allows us to solve problems involving triangles that are not right triangles. What we're going to do in this lesson is show how we can solve side angle angle or angle side angle triangles, and how to solve side angle triangles, and then solve some applied problems. First of all, let's talk about oblique triangles. In this triangle here on the left, all the angles are acute. In other words, they are less than 90 degrees. An obtuse triangle has an angle that's more than 90 degrees. Obviously, it can only have one that's more than 90 degrees. Otherwise, it would have more than 180 degrees in the triangle. Oblique triangle. What we want to show in this picture is that when we start to solve a general triangle that could be oblique, we want to label very carefully the sides and the angles. So you might start first labeling angles A, B, and C with capital A, capital B, and capital C, and then look opposite the angle and label it A. Look opposite angle B and label that side little b, and look opposite angle C and label the other side side C, little c. We're going to be looking at several cases of solving triangles. If we're given one side and two angles, we call these problems angle, side angle, or side angle, angle. If we're given two sides and the angle opposite one of them, they are known as side angles. And then if you're given two sides and the included angle, they're known as side angle side. And if three sides are known, it's called a side, and you want to find the angles involved. The first two are going to be solved using the law of sines, and the other two will be solved, case 3 and 4 will be solved using the law of cosines. Now here is the law of sines. It says if you have a triangle with sides A, B, and C and opposite angles, capital A, capital B, and capital C, respectively, it says that sine of A over A equals sine of B over B equals sine of C over C. It's also true that you can turn everything upside down if you want to and say that A over sine of A equal B over sine of B equals C over sine of C. Both equations work just as well as the other, and I've used both variations. Now, law of sines, just to repeat it, sine of A over A equals sine of B over B, sine of A over A equals sine of C over C, sine of B over B equals sine of C over C. and that A plus B plus C equals 180 degrees. 180 degrees in a triangle. Now we're going to solve a side angle and an angle side angle triangle. We're going to use the law of sines to solve this triangle we see here on the right. We're given an angle of 40 degrees and an angle of 60 degrees. We're given that A is equal to 4. And we want to find B and C and angle C. Now, first of all, let's solve for angle C, because we know A plus B plus C is 180 degrees, and we have that A and B are 40 and 60 degrees. That means that C is equal to 80 degrees, so we can go ahead and put down that C is equal to 80 degrees. And then let's write down the law of sine. Sine A over A equals sine of B over B equals sine of C over C. Notice that we have sine of A because we know A. We know that little a is 4. We know angle B, so we could easily solve for B. So let's do this. Let's plug everything into the first two equations, and we get sine of 40 degrees over 4 and is equal to sine of 60 degrees over B, which we want to find. And solving for B, cross multiplying, we see that B is going to be 4 sine of 60 degrees divided by sine of 40 degrees equals 5.39. Now, plugging in to the other equation, sine of C over C, we got that sine of 40 degrees over 4 is equal to sine of C, which is sine of 80 degrees divided by C. Now cross multiplying, we get that C is 4 sine of 80 degrees divided by sine of 40 degrees, which equals 6.13. In the next example, we're going to use the law of sines to solve an angle side angle triangle. We're given the triangle here on the right, and we know angle A, we know angle B, we know side C is 5, and we want to solve for angle C and side A and side B. First of all, let's solve for side C, or for angle C, which is the easiest. A plus B plus C is 180 degrees. Plugging in for A and B, we get that C is equal to 130 degrees. So this is 130 degrees. It's our obtuse angle. And then we write down the law of sines. Since we're given something about C, we can, and we know sine of A and sine of C, we can plug in and get sine of 35 degrees over A equals sine of 130 degrees over C, which is 5. Cross multiply, and we get that A is equal to 5 sine of 35 degrees divided by sine of 130 degrees, which is 3.74. So A is 3.74. Then write down the part of the law of sines that involves side B and angle B. Sine B over B is sine of C over C. B is 15 degrees, so we have sine of 15 degrees divided by B equals sine of 130 degrees divided by C, which is 5. Cross multiply again, and we get that B is 5 sine of 15 degrees divided by sine of 130 degrees. It's 1.69. Now let's look at solving a side-side angle triangle. In this particular case, depending on what you're given on the sides and the angle, you may have a triangle, you may have one triangle, or you may have two triangles. For instance, if you're given side A and side B and angle A, then depending on what A is, you may or may not have a triangle. Notice, if A is not long enough that it can reach the other side, then you don't have a triangle. Now notice, it's got to be equal to the height of this triangle that of this H I just drew. Notice that sine of A is equal to H over B, the hypotenuse. Now, if A is less than that, then you have no triangle. So, if A is less than H, which is equal to B sine of A, you have no triangle. And in that case, if you use the law of sines, you will get a contradiction, and obviously you'll see that there is no solution. You can have one right triangle if A is exactly equal to B times sine of A. Then the triangle you have is a right triangle. In some cases, you could have two triangles depending on the angles and the sides. Notice that you could have A tilted to the left and have an obtuse angle, and that would be one triangle. The other one would be if A tilted to the right and you have an obtuse triangle. Now, if A is larger than B, more than or equal to B, then you have one triangle that looks like this. Let's solve a side-side angle triangle. Suppose we're given that A is 2, C is 1, and that angle C is 50 degrees. Now, we can use the law of sines, and notice since we have information about C and one piece of information about A, we can write down sine of A over A equals sine of C over C, and get that sine of A divided by A, which is 2, equals sine of 50 degrees divided by C, which is 1. So sine of A equals 2 sine of 50 degrees equal 153. Well, the minute you see something that says that the sine of an angle is is more than one, then you should raise a flag and say this is a contradiction, and therefore there is no triangle. So here's this particular example. C is not long enough to reach if this angle is 50 degrees. Notice if this angle were a lot smaller, it could come and make yourself a triangle. Now, we've got another side-side angle triangle. The triangle with the information given is on the right. We have A is equal to 3, B is equal to 2. Angle A is 40 degrees, and we want to solve the triangle. Notice that write down the law of sine. Sine A over A equals sine of B over B gives us sine of 40 degrees over 3 equals sine of B over 2. Solving for sine of B, cross multiplying, we get sine of B is equal to 2 sine of 40 degrees divided by 3, which is 0.43. So B is equal to inverse sine of 2 sine of 40 degrees divided by 3. And solving for B, you get 25.4 degrees. We're going to call that B1. And notice that there are two angles whose sine is equal to 0.43. The first one is 25.4 degrees. And notice that on the unit circle, there is another point over here. And that angle would be this angle. And notice that this angle here would be 25.4 also. So a possible B2 is equal to 180 degrees minus 25.4 equal 154.6 degrees. So we have a possible B1 is 25.4 and a possible B2 is 154.6. But would this work? Notice that B2 is 154.6 and A is equal to 40, meaning that the sum of A and B2 are more than 180 degrees, so we know we have no triangle if we had a B2 of 154.6. So now we ignore this part and now calculate C using B1, and we get C is 180 minus A minus B1 equal 180 minus 40 minus 25.4 is 114.6 degrees. So now we have angle C is 114.6 degrees. And B was 25.4, And now we can solve for C. Notice that sine A over A equals sine of C over C. A is 40 degrees. Little a is 3. C is 114.6 degrees divided by little c. Cross multiplying, we get that C is equal to 3 sine of 114.6 degrees divided by sine of 40 degrees equal 4.24. So now we've solved for C and solved the entire triangle. And so here's the entire triangle that we just solved. Now we're going to do one more. We're going to use the law of sines to solve a side-side angle triangle. We're given that A is 6, B is 8, and angle A is 35 degrees. In this case, we're going to find that angle A is going to be small enough that we just might have room to have two triangle solution. So we're going to first start out with sine A over A equals sine B over B. A is 35 degrees, little a is 6. We don't know angle B, but we do know side B. So cross multiplying, we get that sine of B is equal to 8 sine of 35 degrees divided by 6. It's approximately 0.76. B1 is equal to inverse sine of 8 sine of 35 degrees divided by 6. Or you could have taken this answer to several decimal places and taken the inverse sine of that. And you'll find that B1 is approximately 49.9 degrees. Now, the other one possibility would be a B2 equals 180 minus 49.9 equal 130.1. Now, is that going to be okay? If B2 is 130.1 and A was 35 degrees, that would leave us room for an angle C that would be basically C would be equal 180 minus A, which is 35, minus B2, which is 165.1 equal 14.9 degrees. Now the C1 would be 180 minus A minus B1 is 95.1 degrees. So now we've got two triangles, one with C1 equal 95.1 and B1 equal 49.9. The other one with C2 equal 14.9 and B2 equals 130.1. Now we just need to solve for the other side. So the third side, C, obeys the law of sines, so we write down sine of A over A equals sine of C1 over little c1. Plugging in 35 degrees for angle A, little a is 6, C1 was 95.1, and little c1 is what we want to solve for. So little c1 is equal to 6 sine of 95.1 divided by sine of 35 degrees, which is 10.42. Now, using C2, we plug into the same formula. Sine A over A equals sine of C2 over little c2. Plugging in and cross multiplying, we get that C2 is equal to 6 sine of 14.9 degrees divided by sine of 35 degrees, which is 2.69. Now we can put both of these triangles together on the other side, and we see two possibilities. We see the smaller triangle with a very acute angle of C2 is equal to 14.9 degrees. And then we see that would be with C2 equal 2.69. If you take the other one with C1 equal 1042, we get the larger triangle. And that shows you the case in which you can have two triangle solutions. Now let's look at solving applied problems. Let's say we wanted to find the height of a mountain. And we have our surveyor who is 2 meters tall. It's over six foot tall. And he looks at the peak of a mountain, and from his point, about 6 meters up, he sees an angle of elevation of 35 degrees. Then he moves closer by 950 meters and then sights the top of the mountain and measures a angle of elevation of 53 degrees. So we want to find out what the height of the mountain is from those two measurements. So let's draw triangles here. Here's 2 meters representing the height of the man. And the height of a mountain above his head is going to be called B. And of course, when we finally solve for B, we'll add 2 to that and have the height of the mountain. We label the hypotenuse of the larger triangle C. And notice that angle C is going to be 180 degrees minus 53. So C is 127 degrees. That also means, since A plus B plus C is equal to 180 degrees, that A is going to be 180 minus 35 minus C equal 18 degrees. So this angle up here is 18 degrees. So we have this angle is 127 degrees. Now, using the law of sines, and since we have A is 950, so sine A over A, which is sine of 18 degrees over 950, equals sine of C, which we know, sine of 127 degrees, divided by C. And cross multiplying, we get that C is 950 sine of 127 degrees divided by sine of 18. That means that C is 2455.22. Now notice that what we want ultimately is B. But now using the hypotenuse, which we know, and the opposite side, which we want to know, we know that sine of 35 degrees is equal to B over C. So B is 2455.22 times sine of 35 degrees, which is 1,408 meters. So the height of the mountain then would be 1,408 plus 2 meters, which is the height of the surveyor, would be 1,410 meters. Now, the last problem is a rescue at sea. We're given two Coast Guard stations, one called Zulu, one called X-ray, and they're 120 miles apart. And each one cites a ship that needs rescue. And they're trying to figure out which one is the closest to the ship. And taking a bearing, they find out that the bearing of the ship from Zulu is north 40 degrees east. So we have an angle here at 40 degrees. Looking at this triangle we've constructed, this angle would be 50 degrees. The bearing to the X-ray is going to be 30 degrees and making this triangle 60. And we want to know how far is each station from the ship. And if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? So, first of all, solve for angle C up here. That would be 180 minus 50 minus 60 equals 70 degrees. Now we can use a law of sines to say that sine of 50 degrees over A, which is one distance, equal sine of 70 degrees over 120. Solving for A by cross multiplying, we get A is 120 sine of 50 degrees divided by sine of 70 equals 97.82 miles. Also using the law of sines with B, the B angle and the B side, we get sine of 60 degrees divided by B equals sine of 70 degrees over 120. And B is equal 120 sine 60 degrees divided by 70, sine of 70 degrees equal 110.59. So the closest ship is 97.82 miles. And 97.82 miles. How long will it take to reach if it goes 200 miles per hour? Distance equal to rate times the time. The distance is 97.82. is equal to 200 miles per hour times the time. So the time would be 97.82 divided by 200. Would be 4891. 0.4891 hours. And that's the lesson for today.